Good afternoon, student. Today we will study the Ehrenfest Theorem. The theorem states that the quantum mechanics gives the same result as the classical mechanics for a particle for which the average or expectation value of dynamical quantities are involved. It means that if a moving particle is associated with the average value of its dynamical variables, then the average motion of the wave packet associated with the particle is analogous to the Newton's law of motion. Hence, for one-dimensional motion of the particle, we have d expectation of x dt equal to expectation of the p upon m, and d by dt expectation of the momentum equal to expectations of the force. We will get these two equations if the quantum mechanics gives the same result of the classical mechanics for the particle for which the average of expectation values of dynamical quantities are the involved. To show that this first equation, we consider the x be the position of the position coordinate of the particle of mass m at time t. Then the expectation value of x is given by, this is the expectation value of x. It is defined by the integration from minus infinity to plus infinity psi star xt into x psi xt dx. This is the equation number 1. That xt represents the coordinate of the wave functions. If we differentiate this equation 1, we get differentiate with respect to t, then we get d expectation of x upon dt equal to integration from minus infinity to plus infinity. We will take this x here, then differentiate this psi into psi star with respect to t, then we get del by del t psi into psi star dx. This is the dx. This is the equation number 1. After differentiating the psi and psi star, we get psi star by using the product rule here. We get this term, we write this integration here, minus infinity to plus infinity x, then differentiate this psi into psi star, then first term remains constant, integration of the second. It becomes psi star del psi by del t plus first become constant, the derivative of the second term del psi star by del t whole into dx. This is equation number 3. Now using the Schrodinger one-dimensional time-dependent wave equation. This is the one-dimensional time-dependent wave equation. Minus h cross square 2m del 2 psi upon del x square plus v psi equal to ih cross del psi by del t. This v is the potential energy. Now separating this term del psi by del t, we will get del psi by del t equal to 1 upon ih cross in bracket minus h cross square upon 2m del 2 psi upon del x square plus v psi. Just taking this term here, we take this ih cross here, we get del psi by del t term. Then this term is written here, del psi by del t equal to this. Now similarly, if we take the complex conjugate of this term psi, then it become del psi star by del t, which is equal to 1 upon minus ih cross. If we take the complex conjugate of I, it become minus I. Therefore, here is the minus sign. Therefore, it become 1 upon minus ih cross. In bracket, this is the minus h cross square twice m del 2 psi. This complex conjugate of psi is a psi star. Therefore, it is written here psi star upon del x square plus v psi star. This is the same equation, just only taking the complex conjugate of this equation. It gives this equation. Now, substituting this value del psi by del t and del psi star by del t in previous equation, means in equation 2, in equation 3, here we have to substitute the del psi by del t and the del psi star by del t value. Then this equation 3 becomes here. After substituting, we get integration from minus infinity to plus infinity x in bracket psi star at the place of del psi by del t. We substitute this whole value. We will get 1 upon I h cross minus h cross square upon 2m del 2 psi upon del x square plus v psi plus psi. Again substitute this value at the place of del psi star by del t. We substitute this value, then we get this. Then this I 1 upon I h cross is common here. Take this outside, we will get 1 upon I h cross. Then integration from minus infinity to infinity x. Remaining term is a x star minus h cross square upon 2m x psi star del 2 psi upon del x square plus this into this term we will get psi star v psi. Here we take only IH cross common here. Here is the IH cross. Then it become minus term. This minus become plus here. Okay. Here is the minus sign and this is the minus. Minus become plus. Then we get h cross square upon 2m psi del 2 psi star upon del x square. Again here is the minus into plus minus. It become minus psi into v psi star. Okay. These two terms are the same. Therefore, they will cancel. Plus minus. They will cancel with each other. Then the remaining term become this. Here again the remaining h cross square by 2m. H cross square by 2m is common here. After cancelling it. Then take this common outside the bracket. It become 1 upon IH cross minus h cross square upon 2m. Here we take the common minus h cross square upon 2m after cancellation this term. Then we get integration from minus infinity to plus infinity x. Remaining term in bracket psi star del 2 psi upon del x square. We take the minus h cross square 2m common. Therefore it becomes minus. Here it will get minus psi del 2 psi star upon del x square dx. Okay. Now differentiate this term. Now integrate this term by parts formula. By using this formula. This is the integration by parts formula. Here we consider this x is the first term means u and v is the second term means this is the complete term u. Then apply this formula here and integrate, we get this term. After applying this formula by parts, integration by parts formula and integrate this term, then we get this formula. D by dt expectation of x equal to IH cross upon 2m. Here h is cancel 2m. This is 1 upon I minus 1 upon I. Here multiply and divided by I means we get the I upon I square. Again we will get minus sign. Minus will get plus means like this. Here if we multiply and denominate by I, then we get I minus I h cross square and denominator become I square 2m. Here h is get cancel. I square is again minus 1. Therefore, this minus become plus. We will get IH cross upon 2m. Here we will get IH cross upon 2m. Here by applying this formula, we will get x means this u is the x. Integrations of the second term. There is the derivative term. Integration and derivation get cancelled. The remaining term is a bracket term. Is a psi star del psi by del x plus minus psi del psi star by del x. Integration from minus infinity to plus infinity. And the second term is the derivative of the first term. Means derivative of x with respect to x, it become 1. Then the integration of the second, it again that integration and the derivative get cancelled. Whole integration means this term minus integration to plus infinity. This bracket term into dx this. Now in a first term, if x tends to minus infinity to plus infinity, then this psi also tends to 0. Then psi tends to 0 means psi del psi by del x also tends to 0. It means that this complete term become 0 by substituting this limit value. If this term becomes 0, then the remaining term is here only. Then we get d by dt expectation of x equal to minus I h cross upon 2m integration from minus infinity to plus infinity psi star del psi by del x minus psi del psi star by del x dx. This is the remaining term. This is equation number 4. Now the expectation value of px is, again we define the expectation of the momentum. Here we get the definition minus infinity to plus infinity psi star p psi dx. This p is nothing but the minus I h cross del by del x. We substitute this value here. It become minus I h cross integration from minus infinity to plus infinity psi star del by del x into psi means del psi by del x dx. We get this value. After rearranging this, we get my integration from minus infinity to plus infinity psi star del psi by del x dx means this complete term. We will take this IH cross here means it become 1 upon minus IH cross into expectation of px. Now take the complex conjugate of this term. It again become complex conjugate of psi star means psi and psi means psi star. Therefore we get psi into del psi star by del x dx. Here again complex conjugate of I means minus I. It minus minus become plus. Therefore here we get 1 upon IH cross expectation of px. Now substituting this value, integration value here in equation 4. If we separate this term, we get the integration from minus infinity to plus infinity psi star del psi by del x minus integration from minus infinity to plus infinity psi del psi star by del x dx. This is equation number 4. Therefore, substitute this integration value in equation 4. After substituting this value, we will get dx by dt IH cross 2m. After substituting, we get 1 minus 1 upon IH cross expectation of px minus 1 upon IH cross expectation of ps. This is the integration value. We substitute here. We get this value. This is nothing but the minus of 2 IH cross expectation of p. Here 2 get cancelled. IH cross get cancelled and minus minus become plus. The remaining term is the expectation of p upon m. Here it means we show that d by dt expectation of x is nothing but the expectation of p upon m. We prove this first equation. Then the second equation is to show that the d by dt expectation of p is nothing but the expectations of the f. F is the force. Here again we consider the expectation value of the momentum p is defined by here we define the expectation of momentum. We will get minus IH cross integration from minus infinity to plus infinity psi star del psi by del x ds. We write here directly expectation value of the p minus IH cross integration from minus infinity to plus infinity psi star del psi by del x dx. This is the equation number 6. Now differentiate this equation 6 with respect to t. After differentiating, we get minus IH cross integration from minus infinity to plus infinity. Here we integrate this, differentiate this term. Again apply the product rule here for the derivative this term. This becomes derivative of first term del psi star by del t del psi by del x plus psi star del 2 psi upon del x del t into dx. Now the time dependent Schrodinger wave equation is IH cross del psi by del t equal to minus h cross square twice m del 2 psi upon del x square plus v psi. Then take the complex conjugate of this term. Here we get I become minus I h cross del psi star upon del t equal to minus h cross square upon 2m del 2 psi star upon del x square plus v psi star. This is the complex conjugate of this equation. The equation number gives the equation number 8 and 9. Now differentiate this equation 8 with respect to x. If we differentiate this equation 8 with respect to x, we get IH cross del psi by del t. Double derivative means del 2 psi by del x del t. We have to differentiate with respect to x. Equal to minus h cross square upon 2m. If we again differentiate, it become del 3 psi upon del x cube plus del by del x v psi. This is the v psi. Now, substituting the value of minus IH cross del psi star by del t and minus IH cross del 2 psi upon del x by del t from equation this 9 and 10 in equation 7. By using this 9 and 10 equation, we have to substitute this value for this value and this value in equation 7. After substituting this value, we get integration from minus infinity to plus infinity at the place of IH cross del psi star by del psi star by del t. We substitute this value from equation 9. We get minus h cross square upon 2m del 2 psi star upon del x square plus v psi star into del psi by del x plus here after substituting this value, here we get this term minus psi star. After substitute this value here from equation 9, we substitute here into dx. Now separate this term minus h cross square 2m. Here minus h cross by 2m. Here we take this term of h cross square by 2m. Here we take the h cross minus h cross square upon 2m integration from minus infinity to plus infinity. The remaining term is the del square psi star del x square into del psi by del x minus. Here is the psi star into del 3 psi by del x cube. Here we write into dx. Then the remaining term is a v psi star. Here we write this term integration from minus infinity to plus infinity v psi star del psi by del x minus psi star del by del x v psi into dx. Again take the del by del x common from this bracket. From this bracket we take the common del by del x. Then we get minus h cross square upon 2m integration from minus infinity to plus infinity del by del x. By taking the del by del x common, the remaining term is the del psi star by del x by del x minus psi star del 2 psi by del x square, because we take the common del by del x. Therefore, remaining term is a del 2 psi upon del x square into dx. Here we get v psi star del psi by del x minus. Here we differentiate this term. Then we get psi star. Then psi into del v by del x plus v del psi by del x. Here again we apply the product rule here. We get this term into dx. Now it becomes here the integration and derivative term get cancelled. Then the remaining term is a minus h cross square upon 2m in bracket del psi by del x del psi star by del x minus psi del 2 psi by del x square. Here and the limit is minus infinity to plus infinity minus. Here v psi star del psi by del x and psi star v del psi by del x. This is the common term. Here after multiplying this psi star here we will get psi star v del psi by del x, and this term is the same. Then this both term get cancelled and the remaining term is a minus psi into psi star into psi del v by del x. Here the remaining term is only this. These two terms get cancelled after multiplying. Then the remaining term is dx. Now, if x tends to plus minus infinity, then psi tends to 0 and also the psi star also tends to 0. If psi tends to 0 means its first derivative also tends to 0, means after substituting this limit value, this bracket term become 0. Therefore, this term completely becomes 0 and the remaining term is only this. Therefore, this become d by dt px, expectation of px is equal to minus integration from minus infinity to plus infinity psi star del v by del x psi dx. This equation, this is nothing but the expectation value of the v. This is the definitions of the expectation value of del v by del x. Therefore, we write here d by dt expectation of px is equal to minus d expectation of del v by del x. But del v by del x minus del v by del x is nothing but the f of x. It is the classical force. Therefore, this equation become d by dt expectation of px which is equal to expectation of x. This equation represent the Newton's second law of motion, and hence these two equation, this is second equation and the first equation is proof here, is satisfied here. This is the first Ehrenfest theorem. So this is the first equation of Ehrenfest theorem, and this is the second equation that represent the Newton's second law of motions. Thank you.